spend the rest of your life testing. You shade above or below. Done. So if you had picked wrong, you would have known right then. Hey, wrong. Shade the other side. I made a bad choice. Erase. Shade the top. The only time it can really trick you is a dotted line, but even that you can test the point off of if you're not sure whether to dot it or not, whether to include it or not. Good. You wouldn't have made a solid line to begin with. When you had your 2 points, you would have done a dotted line. Or take your pencil and erase little parts of it. Dotted lines, if that equal is not on the symbol, if it's only less than or greater than. Absolutely. Yep, that's the only difference. Let me write that. When you have less than or greater than, you have a dotted line. When you have either one of these, you have a solid line because it includes your line. You also just learned that any less than, we don't care which one you're talking about, if it's a less than, you shade below. And if it's a greater than, you shade on top. And that's the new set. I'm going to keep practicing it with you for a few minutes, but that's it. We're still just going to graph that way. Set the thing equal to y first, and then when you're graphing it, do this. Not so bad. Not so much new stuff. To check your answers, you can plug the x and y in just like always to see if it's true or false. So you guys connecting concepts okay? Do you see how this is like the grand finale of everything you've learned so far? I mean, you're okay with this. Before we do more examples, I just want to do some more kind of concept stuff without doing a gazillion examples. I just want to say, note, let's just look at some different things that can happen. If I had a line like this, and I wanted greater than or equal to, where would I shade? If I had an equation, and remember guys, when I'm saying greater than or equal to, that's because y is on the left. You've got to be careful with that. Very big deal. Much bigger deal now than ever before. Y is on the left of that symbol and everything else is on the right, okay? Otherwise, no go. You can't graph it. Y greater than whatever this junk over here was on the right that we don't see. Am I shading on top or on bottom? Top. Okay, top. Good. Greater than, shade on top. So any x and y points that I picked that are above this line would be solutions, including on the line, really. Good to know. That was an x and a y, by the way. We always have x and y axes that we don't take them for granted. We write them. Oh, here's one. I'm going to say y is less than or equal to this line. Less than, top or bottom? Good. I guess I should color a little closer. It's like a coloring lesson. All you got to do is figure out where to shade. Good to know. Y is less than or equal. That's supposed to be a solid line. Please ignore the fact that it's not. What's below it? The stuff here on the left or the stuff here on the right is below the line. Okay. Sure. The stuff over here. So let's color. I'm doing less than or equal. I'm doing equal to for everyone because I'm too lazy to make dots. You guys are okay with that, right? The coloring's the same. Oh, here's a trick one. Trick. Going to write it right here in a different color that hopefully will actually make a solid line and not that. Try that one more time. Trick. What if, I'm going to even make this one a dotted one to make your brains even hurt worse. What if I had something like x less than 5. I can put a number there for you just for kicks. Here's your line. I went ahead and graphed you a line of x equals 5. Remember that's a vertical line when it's x. What in the world less than? Well, this is not what we were prepared for. We said on top or on bottom. We did not say this line that's straight up and down. Let's go back into our memory box and see if we can make a connection. X less than 5. We've seen similar scenarios, haven't we? Would we be shading to the left or to the right? Oh, okay. So we just look at the number line and shade to the left. You got it. Good. And just like before in that opening example, where we had an open circle here at 5, this time we had a dotted line at 5 to symbolize the same thing that open circle symbolized. Good. Now let's do a few examples. We'll start from scratch and I'll give you guys a break. After break, again, if you guys want to see some calculator stuff, I'll be happy to do an example or two on the calculator. It doesn't take long. It's pretty cool. But if your brains are fried and you just want to focus on doing it on paper, I totally understand. I have no problem just teaching you before the final. If you want, like at the end, for some extra study tips, I can teach you stuff. Whatever makes you guys comfortable. So let's practice from your textbook. Page 281 is where we're at in the text. And I'm going to pick like 2 of them. So I think I'm getting exhausted and you guys can start practicing. Let's see. How about first? Ooh, number 8. That's a good one already. That early in the examples, really? Number 8. We want to graph the solution set for this. Before we graph this, we rely on something. Our old graphing friends. We want this equation. And we want to remember that multiplying or dividing by a negative flips my sign. Other than that, we are good to go. Getting y by itself was the first thing you guys did. Move 4x. When you're moving something, you actually make it a negative, right? That falls off. We have negative 3y less than or equal to. Can I put the x first just to make me feel happier inside? Is that okay? Okay, negative 4x and a positive 12. Remember, order doesn't matter, but I'm just trying to make it pretty to keep us all happy. I could have put 12 minus 4x. If you did that, leave it. Who cares? I want y by itself. What shall I do? Everywhere, right? Hopefully there's a red flag here. I'll put a red star. Yep, because we were dividing by a negative. So now you have y greater than or equal to, because we divided by a negative, right, guys? It goes into both pieces. We're going to have 4/3 x. What's 12 divided by 3? Okay, minus 4. Let's graph this thing. I'll give you guys a moment to make sure your algebra matches mine. That was the hardest part, in my opinion. That's just my opinion, though. Maybe it doesn't count. When we're graphing, guys, are we using a solid line or a dotted line? Solid because the equals is included? Okay. Let's go ahead and graph it, and we'll think about the line in a second. So I'm going to go ahead and make my x and y axis. X, y. Let's put our little tips that point forever on there. Crosses the y-axis where? What's my y-intercept? Put a dot there. Slope. Let's see. Slope. So it's right there, right? It's up and over, right? Okay. Up 4, 1, 2, 3, 4 over 3. We said solid line, so I'll go ahead and put a solid line. Oh, it's so beautiful. I don't even know what to say. I hit both dots. It's a rarity in this class. Okay. Greater than, is that on top or on bottom? Is today really this easy? Talk is free present. Are we okay? If it's not easy, don't be frustrated. It's just practice till it is. Honestly, that's probably the hardest problem you're going to have. I mean, other than 19 and 20, which I just did when you have X, the graph left or right, depending on the sign. Do you want to see one more of that? No? Let's take a 2-minute break. You guys can come back and work. If you want to see the calculator thing, I'll be happy to show you the calculator, or you can just work, and that's fine. Whatever floats your boat.